Mela, today, students, we're going to start the second lesson on transformations. Today, we're going to speak about rotations. Now, in this lesson, we're going to see two things. Number one, how to perform rotations, which are the different types of rotations, and how to do them, how to use rules. Also, we're going to form rules for the three different types of rotations. We're going to have rotations from the origin and rotations from a point which is not the origin. And then also regarding rotations, we're going to see how to find the center of rotation when the angle is right angle, because even 180 degrees, but the most difficult one is when it's rotated through 90 degrees and the center of rotation is not the origin. So the three types of rotations are: number one, a rotation by 90 degrees clockwise. Number two, a rotation by 90 degrees, this time anti-clockwise. And number three is going to be a rotation of 180 degrees. It doesn't matter if it's clockwise or anti-clockwise. First part of the lesson, these three are going to be all from the origin, meaning from the point 0, 0. So let's start by seeing an example, because from the example we're going to form the rules. So example, plot triangle ABC. Now we're going to become accustomed to this triangle, where A is the point 2, 1, B is the point 5, 1, and C is the point 5, 3, our usual triangle. We're going to rotate triangle ABC. Rotate triangle ABC from the origin by number one, 90 degrees clockwise. Number two, 90 degrees anti-clockwise. And number three, by 180 degrees. Okay, so I'm going to plot the triangle, and then we're going to do the three transformations, the three rotations. So that's our grid. I'm going to plot, draw the axis, the y-axis and the x-axis. I have 0, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and 6, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so our triangle A2, 1, A2, 1, B5, 1, and C5, 3. So that's our triangle. Let's draw the triangle. That's our original triangle. Triangle ABC having those coordinates. So our first rotation was a rotation 90 degrees clockwise from the origin. So we're going to rotate this shape from the origin. Okay, so if I had to draw a right angle, the right angle will look something similar to this. That's our right angle. So rotating A by 90 degrees from the origin, this is our right angle. We find that A comes here. Let's see what's happening. A has a coordinate 2, 1. We rotated A, and our new coordinate for A is 1, -2. Let's compare the two coordinates. So I had 2, 1, which became 1, -2. If one sees what's happening here, the x and y axis have been swapped, and also the y-axis now from positive became negative. So if we consider point B having coordinate 5, 1, if the same thing is going to happen, we'll see that B will become 1, minus 5. Let's check 1 minus 5. 1 minus 5 is here, so that should be our B. 1 minus 5. Let's see also what's going to happen to C. C is 5, 3. Rotating C by 90 degrees. So it's going to be swap coordinates. Those are going to be swapped. 3, 5. But the y-axis is going to be negative, so it's going to be 3, minus 5. Let's see 3, minus 5. Yes. Let's see 3, minus 5. It seems to be correct. Let's draw the triangle so that we'll be 100% certain that is correct. So I have triangle ABC. That's our rotated triangle. Okay, so that's the rotation. That's the rotation by 90 degrees clockwise from the origin, from the coordinate 0, 0. Okay, that's a correct rotation, as you can see. So the rule for this transformation, as we've seen through this example, we have to swap the coordinates and then change the sign of the y-coordinate. So let's write down the rule for the first transformation. So rules, first rule, rotation of 90 degrees clockwise from the origin. The rule states that we have to swap coordinates. Swap coordinates. Then change sign of y-coordinate. It means that the point P x, y will become the point y, minus x. Y minus x. Alright, so we have swapped coordinates. xy became yx. We have changed the sign of the y-coordinate. To remember this rule and which sign you need to change, remember that looking here, I'm going to highlight, looking here at this number, alright, we see that the 90 degrees clockwise, the arrow which symbolizes clockwise, is on the y-coordinate side of a set of coordinates, okay, x, y. So after swapping the coordinates, change sign according to the arrow there. That's a nice trick for this rotation. So the second rotation now is going to be a 90 degree anti-clockwise. I'm going to do same thing as I did with the other one. If I'm going to imagine a 90 degree clockwise, anti-clockwise rotation, I'm going to find this angle of 90 degrees. There's an angle of 90 degrees. Let's draw it. Let's see it, because it becomes quite simpler now. I have an angle of 90 degrees. This time on the other side, on the other side of the board, of the axis. So according to our calculations, that's going to be our coordinate A. So rotating A by 90 degrees anti-clockwise, we've got minus 1, 2. Let's check what's happening. So from 2, 1, it's become minus 1, 2. As we can see, the coordinates have been swapped to 1, 1, 2, but this time we have changed the sign of the x-coordinate. If the same is going to happen with the other ones, so let's check B 5, 1. It's supposed to be minus 1, 5. So that's supposed to be our B. And 5, 3, which is going to be minus 3, 5. And yes, let's see. Let's draw the triangle. It becomes more clear now. So there we have it, our triangle. Alright. So now we have our rotation. Let's write down this minus 1, 5. This has a coordinate minus 3, 5. So now this is a rotation. That is a rotation 90 degrees anti-clockwise from the point 0, 0. Okay, so that's a nice rotation anti-clockwise. So let's write down the rule. The rule is very similar to the other one, but this time instead of changing the sign of the y coordinate, we're going to change the sign of the x coordinate. So a rotation of 90 degrees anti-clockwise from the point 0, 0. I need to swap coordinates. Then change the sign of the x coordinate, meaning the point x, y is going to become the point minus y, x. Minus y, x. Again, remember, let me highlight this. If you look at that, you'll be able to see that the symbol for the anti-clockwise rotation is on the left-hand side of the 90 degrees, meaning that after solving coordinates, you change the sign of the left-hand side, which is the x coordinate. Let's draw our last rotation, which is a rotation of 180 degrees. So we have our original shape ABC, and we need to rotate that by 180 degrees from the origin, meaning that now the angle is 180 degrees. 180 degrees means that it's very easy to draw the 180 degree. That's our 180 degrees. It's going to be on that side. So it's clearly visible that now this is A, that is A. This is B, is going to be on the other side. Let's see what happened to A. This is minus 2, minus 1. So 2, 1 became minus 2, minus 1. If we compare the two coordinates, we can clearly see that the axis remained the same, x and y coordinates remain the same. Only the signs have changed. So translating that, if we have b 5, 1, we're going to change the sign. It's going to be minus 5, minus 1. So this b minus 5, minus 1. And we have c, which is 5, 3. It's going to be minus 5, minus 3. Let's see. C minus 5, minus 3. Let's draw the triangle. I'm going to see it clearly now. We have our triangle. Oh, no, triangle. This is our triangle. So now we have here a rotation of 180 degrees. Okay, so as we have seen, the coordinates remain the same, but the signs changed from positive this time to negative. So we're going to write down the rule. The rule is now quite simple. So a rotation of 180 degrees, from the origin means that all we need to do is change all signs. Meaning that the point x, y will become my new point minus x, minus y. Okay, so these are the rules for rotating a shape by 90 clockwise, 90 anti-clockwise, and 180 degrees. Now, what happens when the center of rotation is not our origin, is not the point 0, 0? For this, we need to use the rules, but we have to do something else. So if you have to do something else, even marks in the exam will be more, okay? So you have to need to be careful to that. So let's see an example. So I'm going to plot triangle ABC, having coordinates A2, 1, B3, 5, 1, and C4, 3. I have changed a little bit our original triangle. I'm going to rotate triangle ABC. We're going to rotate triangle ABC by 90 degrees clockwise this time from the point -2, 3, and we'll see what's going to happen. So I'm going to plot our triangle first. So we have our axis 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and 6, 1, 2, 3, -4, -5, -6. We have our 0. Triangle was A2, 1, A2, 1, B5, 1, and C4, 3. And C4, 3. So let's draw the triangle. This is our original triangle. Now, we need to rotate, as we have seen here, we have to rotate triangle ABC 90 clockwise from the point -2, 3. So let's find the point -2, 3. The point -2, 3 is here. So we need to rotate that triangle from that center of origin now, which is P. So what am I going to do? Well, the following method can be used. I'm going to measure distances from P to A to B and to C. So if I try to write what's going to happen, well, to go from P to A to B and to C, I need to move X and Y distances as follows. Now these are not coordinates but X and Y distances. Well, from P to A, I need to move 2 down and let's start from X. From P to A, I need to move 1, 2, 3, 4 to the right, so +4, and I need to move 2 down, so +4 and -2. So moving 4 to the right and 2 down, I get to A. Moving 7 to the right and 2 down, I will arrive to B. While to arrive to C, I need to move 1, 2, 3, 4, 5, 6, and remain where I am. So that's 6, 0. So, rotating those by 90 degrees clockwise, 90-degree clockwise, I get my new points. So I get the new points from P to A, from P to B, and from P to C. Let's see what these are. So, rotating 90 clockwise, I need to swap distances, so I get -2, 4, I get -2, 7, and I get 0, 6. But 90 clockwise, we had to do two things. We had to swap, then we had to change the sign of the Y. So those are negatives. Now, those are not coordinates, but distances. So I'm going to count the distances. So from P to my new point A, -2 on the X, so it's -1, -2. And I have to go down 4, so it's -1, -2, -3, -4. So that's my new point A. Let's find B. B, I have to go -1, -2, -1, 2, 3, 4, 5, 6, and 7. So this is B. To go to C, I have to remain where I am, 0, but I have to go down 6. So it's 1, 2, 3, 4, 5, and 6. So that's my new point C. So let's check, let's draw the triangle. We have our triangle. And that's our reflection, so our rotation. So this is a rotation. This is a rotation of 90 degree clockwise from the point P minus 2, 3. We can check our answer by choosing one coordinate. I'm going to draw I'm going to draw 2 from P to A and from P to A, and we can use our protractor to check that that angle is a right angle in fact. Okay, as you can see, we have a right angle there, that's a right angle, that's a 90 degree. We have rotated that triangle 90 degrees clockwise from that point. This is a little bit more difficult, it has more work, you have more work to do. But in exams it's worthwhile. That has 4 or 5 marks in exams. Hope you understood this part. Now for the last part of the topic, I'm going to explain how to find the center of rotation. If it's 180 degrees, it's very simple. But if it's 90 degrees, we have to use constructions. So let's see an example. So I have a set of axes. One, two, three, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Well, let's see. We've got a triangle. This triangle is going to be rotated. Okay, this is the first rotation. Then we have another rotation. Okay, minus 1, 3, minus 4, minus 5, minus 6. So we have ABC, shape P and shape Q. So we need to find, so triangle ABC is rotated to obtain shapes P and Q. Describe each rotation. Well, from ABC to P, as we can see, the triangle has been inverted upside down. When it's inverted upside down, it means that the rotation is a 180 degree rotation. Now, to find a 180 degree rotation, all you need to do is to join two vertices. For example, A to A and B to B. By the way, if you join C, it will be the same result. Okay, it will be the same result. Okay, so as we can see, the center of rotation is that one. I'm going to draw only two. So from triangle ABC, to P, we have a 180-degree rotation from the point of intersection. Now the point of intersection in this case is minus 2.5, comma 0.5. Minus 2.5, comma minus 0.5. So that was quite easy from one to the other. Now I'm going to show you how to find the center of rotation from the triangle to Q. Now to do that we need to construct when the center of rotation, when the rotation is a 90-degree rotation, we need to find the center of rotation by bisecting two equivalent corresponding by bisecting the distance between two corresponding points, between two corresponding vertices. Let's see this. So if I take A in triangle Q, A is that one. So I'm going to use my compass to bisect distance A. Now let's see this. That is distance AA. To bisect a distance we need to open the compass about 3/4 of the distance. Right, about 3/4 of the distance. Draw two arcs, one on one side, the other on the other side. I need to use the same radius, place it on the other point A, and I bisect my distance. That's 1, and that's 2. So somewhere on that line there is my center of rotation, right? Somewhere on that line. I'm going to draw that line. Somewhere on that line there is my center of rotation. Now what do I need to do? I need to bisect another pair of corresponding coordinates. This time I'm going to choose C and C, or B and B. I'll be choosing B and B. So I have B here. That's my other B. I'm going to do the same thing again by bisecting distance from B to B. So I have my compass. This is distance BB. This distance BB. I'm going to open the compass about 3/4 of the distance. I'm going to use another color so that you can be able to see clearly what I'm doing. I'm going to draw one arc on top, the other arc on the other side. So that's one. I'm keeping my radius. I'm going to point my compass on B now, on the other B. That's my first bisection. This is my other bisection. Be careful. As you can see, this, where my pointer is, that is the center of the two bisectors. So I'm going to draw that bisector from there to there And as you can see, this is the center of rotation. So from the triangle, ABC to triangle Q, I have a rotation of 90 degree clockwise from the point, our coordinate is -2, -4. So that's how to find rotations of 90 or 180 degrees when your rotation is not the center of origin, the coordinate 0, 0. I hope you have understood this. This is about rotations. I'm going to give you a problem which you need to do at home. I'm going to write it down. You have to work it out on your squared copybook. Plot triangle ABC having coordinates A -3, 2, B -6, 2, C -4, 4. Rotate triangle ABC. Number 1, 90 degree clockwise from the point 0, 0. Number 2, 90 degree anti-clockwise from the point 0, 0. Number 3, by 180 degrees from the origin, meaning from the point 0, 0. Number 4, by 90 degrees clockwise, but this time from the point -1, -1. So that's all for today. See you next lesson, which will be about translations.